All right, everyone, so welcome back. We are here for calibration training. That is to say, you are here to learn to become an expert in your own uncertainty. You went through round one, and hopefully this is getting you on track, or at least giving you a sense for what this is all about. It's about providing accurate estimates for model building, models that we're building together. So you went through group one, and you may have some thoughts, some feelings, some doubts. You should take time, if you haven't already, to talk about those. If you're working on this alone, then feel free to write down those thoughts, but do keep track about any feelings or doubts you have, and keep track of your progress. So we are now here because we want to gather some estimates from you eventually. We're doing this training for that very purpose. And it's all for a process that we call parameterization. That is, before we build a decision model, something we're working on with you, very likely, we need values for variables within that model. And we often use distributions to express these values. Rather than give an exact number, we have to express our uncertainty or express issues of variability by giving a distribution to represent a variable. For many variables, we have no data. So we go through this process. You've been working with us to build models. We try to find you and make sure we've framed the decision well. We identify input variables. And for those, we do this model parameterization. Parameterization is where we put those distributions into our model. We gather those distributions. We run the model, do an analysis of the results. If the results offer sufficient guidance, then we can make projections about decision outcomes. Otherwise, we do model refinement and make sure we've identified the right variables and do more parameterization. That's kind of a basic overview of our process here. Within the middle, right in the middle of that process, kind of part of the core of that process is getting these estimates for these parameters. We can get them from historic sources. We can find key informants. We can look for data sets, but we often need to get these estimates from experts. We talk to experts, do an expert knowledge elicitation, and get calibrated experts. That's what you will be able to do. Hopefully by the end of this training, you'll be able to provide us with calibrated estimates. We could make estimates from what we already know. That works sometimes, but there are a lot of biases that can lead us astray if we look only for our experience. It's not a great idea, so we should try to find ways to get rid of our biases. What often happens is that we choose a single number. You may have done that in the previous steps. You may have chosen a very narrow range, and then sometimes that works because we might paint our bullseye later after the fact. But really, we need to have pretty good archery if we're going to make very narrow ranges. So instead, through the kinds of simulations that we build and the way that we can express our uncertainty and express variability with distributions, we can be explicit about our uncertainty, and we can shoot lots and lots of arrows. And sometimes we try, as you may have tried in the previous round one, group one of questions, you may try to shoot a very narrow range. You may try to shoot all of your arrows right where you think the bullseye is. This is often unrealistic when we're talking about the kinds of decision problems that we're dealing with. We're talking about outcomes in the future and lots of variability, lots of uncertainty. So this is often unrealistic. We can be accurate and imprecise instead, where we shoot multiple arrows and we kind of shoot around the target range. We try to include the true value within our distribution and include the variability and uncertainty there. That's sometimes possible. What often happens in this inaccurate and precise option here is probably what happened to you in the previous round. So you thought you had the true value within your distribution, but instead you were shooting a very narrow range, but it was off target. This, of course, is bad. That doesn't help us with the model building procedures. So what we might need to do is to be inaccurate and imprecise. That is to say, shoot quite a broad distribution, shoot quite a number of arrows, create a broad distribution that reasonably reflects our uncertainty around the target estimate. So that can be enough if we really don't know any better. So I'll just give an example from some work we did on nutrition. So an estimate can be a single point or a range. And one example here is how many calories are in 100 grams of mango. Now, people might shout out something like 200. But this, of course, is a bad estimate. It doesn't help us because there's no range and it's almost certainly wrong. Maybe in some of the cases it's correct, but almost certainly wrong in most cases. A non-informative estimate that is a very broad range would be 0 to 1,000. Is to say 100 grams of mango has no calories or half of your daily recommended calorie intake. It's definitely right. It's not very useful, but if that's all if we really don't know, if we don't have background, it may be enough. A good non-expert estimate, someone who's been calibrated, they might give us something like 20 to 300 calories. Accurate, not very precise, but still helpful. But a good expert estimate would tell us that there's somewhere between 40 and 150 calories per 100 grams of mango. That is to say, you can get a green mango or a very ripe mango. You can get mangoes with higher sugar content. And so there's some variability, but it tends to range around these numbers. A good estimated range should contain a correct value. We look for a range with a 90% chance. That's what we're asking you to do in this training. 90% chance of containing the right value. And we call this the 90% confidence interval. That's what you're all working on in these questions. So for all those questions that you're answering that ask for 90% confidence interval, you're expected to get 90% between your upper and lower bounds by definition. You'll probably answer 10 questions. You should get 9 of them correct. And you can, within the app, you can actually determine your level of calibration if you're working in our app by comparing the actual outcomes to the expected outcomes. And someone will show you where that option is.